Hello and welcome back to our course. So in this session we are creating random numbers with the NumPy package. And we have already learned that we can create random numbers with the random module of the standard Python library. However, creating random numbers with NumPy is more flexible and provides a lot more functionality and is also faster, so there's actually no reason to use the random module of the Python standard library when we can use the powerful NumPy random package. So now let's first import NumPy. And then what we would do, we want to create 10 random integers between 1 and 101 excluding. So let's press Shift Tab. And here you can see, so random.randint returns integers from flow inclusive to high exclusive. So if you want the random integers between 1 and 100 including, we have to type here 101. And here the third parameter is the size, so how many random numbers or integers we want to create. And let's execute the cell here. Now you can see we get 10 random integers in the range 1 to 100. And if we repeat this process, we should get different 10 random integers, because it's random. And there's a very helpful instrument called random-seed. So random.seed creates so-called pseudo-random numbers, and it enables us to reproduce the random numbers we create. So whenever you use the same seed as I, so here in brackets, you have to define a number. So here it's 1, 2, 3, but can be any number. And whenever you have the same number here in the random seed, you create exactly the same random numbers as I do. So let's run here the cell. And let's repeat here the process, and we should get the same numbers again, because we didn't change the random seed. Alright. And we can also create normal distributed numbers. I don't want to go in details of normal distribution, but it's kind of a bell-shaped probability distribution where you can determine the mean. So mean is here 5. But it's flexible, and you can determine the standard deviation. So second position is 2. So log stands for the mean, scale stands for the standard deviation, and you can also determine the size. So how many normal distributed numbers you want to get. So when we execute it, we get 10 normal distributed numbers with mean 5 and standard deviation 2. Alright, so let's create an array with numbers between 1 and 100, so called B. And then we can randomly shuffle all elements here, so we can mix all elements up and change the sorting. Now we have to print B. And here you can see, so B is now randomly sorted, or not sorted actually. But there's the method .sort where we can sort again our unsorted array. And let's check the result. Now it's sorted again. And actually, for whatever reason, so the method sort does not provide us the option to sort the array in an inverse order or a reverse order. So I don't know why there's no option for it, but it's the case. But if we want to sort our array in the reverse order, there's a trick here by :-1. There we have the reversed order starting from 100 till 1. And there's another method called random.choice. So random.choice creates a random sample from a given array. So we can have our array B, and then we determine the size of our sample. So for example, 100. And then we can determine whether the sample is with or without replacement. So what does it mean? Whenever an element is randomly chosen, so let's say here 1, in the next step, again, we have the chance to choose this element, and without replacement means that you can choose one element only once. So here we have replacement is true, and we choose or randomly select a sample of 100 elements from our array B. Let's see what we get. Okay, we get 100 elements, and we can then sort our new sample array B1. And there you can see, so we have some duplicates. So we have 2 was chosen 2 times, 4 was chosen 4 times. And with the method unique, we can choose only the unique elements, so we can remove all duplicates. There you can see we have only the unique values without any duplicates. And we would get the same result by transforming our array into a set and then transforming it into a list and then to an array. So we cannot immediately transform a set into an array. So first we have to make a list. And we get the same result here. And now by adding the method size, we can determine how many unique elements we have. Here we determine the unique elements of our sample, and then .size gives us the amount of unique values or elements. So it's 66. So we created 100 integers with replacement and we got back 66 unique elements. And the unique method is quite informative, so it has some more parameters. For example, return index equals true and return counts equals true. So by default they are set to false. Let's see what we get. So here in the first array we have our unique elements, and in the second array we get the index position of the first occurrence of our unique values. So for example, if we go to our array with duplicates, so the first occurrence is 2 is of course at position 0. And the first occurrence of 3 is at index position 2. There you can see here. And also Python returns us an array with return counts. Here we can read that 2 was included in our sample 2 times, 3 was included in our sample 1 time, and 4 was included in our sample 4 times. So this is quite informative here. And we can also set the replace parameter to false here. Yeah, there's actually no surprise because our array contains 100 elements, and if we randomly select 100 elements without replacement, we actually get all 100 elements. So let's check unique elements. So we get all elements from 1 to 100. And yeah, we have 100 unique elements. Alright, so this was a short introduction to the NumPy random package, and we learned how to create random integers, normal distributed numbers, and how to randomly shuffle an array. And also we learned how to make a random sample of an array. And there are many more things you can do with the random module. So for example, let's np random dot, and then if you press tab, there you can see many methods you can apply here. So you can have a log normal distribution and many things. You can have the Poisson distribution and so on and so on. Alright, so this is it for the time being. So this was a short intro to random numbers, and in the next session we will compare the Python standard library with the NumPy package in terms of performance. So hope to see you there, and bye.